In the last section, we saw how we could build a decision tree explicitly and how we could search it, either depth first or breadth first. And that would allow us to find solutions to problems like the knapsack problem. And we'll come back to the knapsack problem in more details in the second part of the course. We're just using it as an example to demonstrate how I can find a nice solution to a particular kind of optimization problem. What we also saw, though, was by explicitly building the tree and then searching it, both depth first and breadth first would still search the same number of nodes. They do the same amount of work here. The order is simply different in terms of how they find it. We might be able to do better, and in particular we can if we're willing to settle for good enough. If we don't want to find the optimal solution to getting the most valuable things into the knapsack subject to some constraints on weight, but we'd simply say as soon as we've got something worth at least this much, stop, then in fact we'll see a different behavior. So let's look at that variation on this. We're going to do almost exactly the same thing. Yes, there's a lot of code here, but it's a very simple change. We're now going to search a decision tree, depth first, but with good enough. So it's going to look almost like before. It's going to have some starting point. It's got the function that we're trying to optimize. It's got the function that we have to satisfy, that the constraint has to be true. And we're going to add in one last thing, which is a stop function. And here's the idea. The search looks just like before. Start off with a stack. I'm going to look at each element in the stack as long as I can. And I notice I got a typo there. That should be stack, not queue. Sorry about that. But I'm going to look at each element in turn. Again, I'm going to check to make sure that I can actually put the thing in. If I can, I'm going to see whether it's a better solution than what I had before. And here's the one change. Once I've checked that out, I'm going to now say, let me try looking at best. And in particular, use a function that I've passed in called stop that looks at the value associated with the node at best. And if it's true, if I've got enough, I'm good enough, I'm simply going to stop and return best. Otherwise, it's going to be just like it was before.